two variable inequalities, two variables because you have x and y. First example, we're going to graph the inequality y is less than 1/2 x minus 3. What form is this in?
Slope-intercept.
Slope-intercept form. Now, with graphing inequalities, the most important part of your graph is the shaded region. You have to shade with inequalities because here's the answer down here. But every point in that shaded area is representing a solution to the inequality. Alright? So that's why that is the most important part of the answer. The non-shaded region is every other point that is not a solution to the inequality. Alright? So we graph it. You already told me it's a slope-intercept form. Just by looking at it, what's your y-intercept?
-3.
-3. You put a point at -3. And your slope?
1/2.
So you rise 1, run 2, put another point, and we draw a dotted or dashed line. What makes it dotted or dashed?
Whether it has
Less than or
greater
equal
than
to, or...
Yeah, if there's no equal to sign with it, and it's not here, then it's dotted. Alright? If there is an equal to sign, then it's a solid line.
So if it's less than or equal to, it's solid?
It would be solid. Now, your shaded region, if it's in slope-intercept form, it might be easy to tell where to shade. And the more of them we do, you'll pick up on where to shade. If it's in standard form, I'm going to show you a different method of figuring out where to shade. Just by looking at it, this is asking you what values of y are less than the line. So here's where the line's crossing the y-axis. Which values on the y-axis are less than this line? All these. That's why I shade below it. Alright, but I'm going to show you another method that will work for slope-intercept form and standard form. Yes?
Where'd you get the 2 over there inside?
Where?
Like,
Over here?
yeah.
I haven't gotten there yet. That's what I was about to show you. Alright, so we're going to figure out a easy method for figuring out the shaded region, whether it's below the line or above the line. This method always works. So if you can't look at it and tell, use this method. What you do is pick any point on the graph that is not on your line. It can't lie on your line. The easiest point to always pick would be 0, 0, as long as 0, 0 is not on the line. If it is, pick another point. So is 0, 0 on my line? No. So I'm going to use 0, 0 and plug it into this inequality and see what happens. So plug 0 in for y, 0 in for x, and solve the inequality. You get 0 is less than -3. Once you get to that point, you ask yourself, is that true or false? That's a false statement. 0 is not less than -3. Alright? So that tells you that the point 0, 0 right here is not part of your shaded region. So if you end up with a false statement, then that means that point that you chose is not part of your shaded region. So you know to shade away from 0, 0 in this case. Then I tested another point. I tested a point inside the shaded region, which I picked 2, -3, which is about right here. All right, and just plugged it in. -3 went in for y, 2 went in for x, and I ended up with -3 is less than -2. Is that true or false? That's true. So that tells you that point, 2, -3, has to be part of the shaded region. So I would shade towards 2, -3, and away from 0, 0. All right? Let's look at another one. Standard form here. So here it's easy to tell where to shade without plugging in the point. But we're going to graph it just like we've graphed standard form. What do we find when we're graphing in standard form? How do I graph in standard form? What am I finding?
You're finding Intercept.
the intercepts, the x-intercept and the y-intercept. So, to get the x-intercept, we had to set y equal to 0, so we're ignoring this basically and solving for x. So what's x?
X is 7, or 5.
5. X is 5. X-intercept is 5. And what's the, to get the y-intercept, I'm ignoring this and solving for y, so what's the y-intercept? 7. And it's a dotted line, or a solid line, because there's an equal to. And is 0, 0 on your line? No, so that's a good point to check. Plug 0 in for x, 0 in for y. You end up with 0 is greater than or equal to 35, which is false. So that tells you 0, 0 is not part of the shaded region. So we don't shade towards 0, 0. We shade away from 0, 0. So every point in this region is a solution to the inequality. Every point below the line is not a solution to the inequality. All right? So, again, the shaded region is the most important part of your graphs here. All right, now, absolute value. We know absolute value. We shade it the same. If you can't look at it and tell where to shade, plug in a point. But we're going to graph it just like we graphed absolute value equations. So for this one, y is less than or equal to x minus 4 plus 5. We should be able to look at this and tell the vertex is what?
4, 5.
4, 5. 4 from here, 5 because of this. All right. Now, the points I chose to the right of 4, here's 4, so right to the right of 4 I chose 5 and 6, and points that correspond with 5 and 6 would be 3 and 2. So that's where I get all my x values. Once you plug in 2, what's 2 minus 4? What's the absolute value of negative 2? 2 plus 5. So that means these two must be 7. And you plug in 3, 3 minus 4. Negative 1, absolute value, negative 1. 1 plus 5, 6, 6. Plot those points. Here's your graph. It is a solid line because there's an equal to sign. All right? If you can't look at it and tell to shade below, pick a point. 0, 0 again is a good point to choose. I ended up with 0 is less than or equal to 9. Is that true or false? True. So if it's true, that means to shade towards 0, 0. So your shaded region is everything below your graph. Question on that? Okay?
What is the exact one?
Say that one more time.
You just found the shaded area.
Oh, okay. Oh,
Right here?
What is exactly for the scratch do?
This is the shaded region.
Okay.
Okay? You can shade it however you want. And if you just want to draw lines, that's fine. Just as long as I can tell where you're representing the answer. Alright? And last, I will give you a graph like that, and you have to come up with the equation. So what you do here is figure out what the vertex is. What's my vertex over there? 3, 2. Then you should easily be able to come up with this, right? If it's a V shape, you know it's absolute value. All right. So if your vertex is 3, 2, you should be able to come up with x minus 3 inside and plus 2 outside. That's nothing new. If we're shaded inside of it, when it's opening up, it's got to be greater than. And how did I know it was equal to? Because it's a solid curve or solid graph.